What if I told you that beneath the ice sheets of Antarctica, something is happening that scientists can't fully explain? The continent is changing faster than anyone predicted, and what researchers are discovering underneath the collapsing ice is rewriting everything we thought we knew about our planet. This isn't some distant future problem. This is happening right now, and you need to hear about it. Make sure to subscribe and hit that notification bell because this story is developing as we speak, and you won't want to miss what comes next. Antarctica, the coldest, most remote, most mysterious continent on Earth. For millions of years, it's been covered in ice so thick that if it all melted, global sea levels would rise over 200 feet. But here's the thing. That ice isn't as stable as we thought. And scientists monitoring the ice sheets have noticed something alarming. Sections of ice the size of major cities are collapsing not over decades or centuries, but literally overnight. Massive chunks of glaciers that have been frozen in place since before human civilization began are suddenly breaking apart and sliding into the ocean. And when researchers went to investigate why this is happening so fast, what they found underneath defied all their models and predictions. Let's start with what's actually collapsing. The most dramatic changes are happening on the West Antarctic ice sheet, particularly around the Thwaites Glacier. Scientists call it the Doomsday Glacier, and that nickname isn't an exaggeration. This single glacier is roughly the size of Florida, and it's losing approximately 50 billion tons of ice every single year. But it's not just the amount of ice loss that's concerning, it's the speed. Satellite imagery shows that parts of Thwaites are retreating at rates that were considered impossible just a few years ago. We're talking about ice cliffs that are hundreds of feet tall suddenly collapsing in massive carving events that send icebergs the size of skyscrapers tumbling into the sea. When scientists started drilling through the ice to understand what was causing this rapid collapse, they made their first unexplainable discovery: warm water. But not just any warm water. Ocean currents carrying water that's several degrees above freezing are flowing underneath the ice sheet, melting it from below. This wasn't supposed to be happening. The models predicted that the ice sheet would be protected from warm ocean water by the cold Antarctic currents. But somehow, these warm currents are sneaking underneath the ice, reaching cavities and channels that are melting the glaciers at their foundation. It's like the ice is sitting on a warming hot plate, and it's being eaten away from the bottom up. Here's where it gets even stranger. When researchers sent robotic submarines and remote cameras into these underwater cavities beneath the ice, they discovered vast networks of channels and rivers flowing under the glaciers. We're not talking about small streams. These are massive waterways, some as wide as major rivers, racing beneath billions of tons of ice. The water in these channels is moving fast, carving out the underside of the ice sheet and creating enormous hollow spaces. In some areas, these cavities are tall enough to fit a 10-story building inside them. And the ice above is essentially floating on these water channels. And as the channels grow larger, the structural integrity of the entire ice sheet is compromised. But the truly unexplainable part came when scientists analyzed the sediment and water samples from beneath the ice. They found something alive. In an environment that's been sealed off from sunlight for potentially millions of years, in water that's barely above freezing, they discovered thriving ecosystems of bacteria and other microorganisms. These aren't just any microbes. Many of them are species that science has never seen before. They're surviving in total darkness, in extreme pressure, in conditions that we thought were too harsh for life. Some of these organisms are feeding on chemicals in the rock beneath the ice, creating entire food chains in a world that's been hidden from us until now. The discovery has massive implications not just for biology, but for our understanding of where life can exist, including on other planets. The geological discoveries are equally baffling. Ground-penetrating radar and seismic studies have revealed something unexpected under the ice. There are mountains, valleys, and lake systems that rival anything we see on the surface of the Earth. But more than that, scientists have detected what appear to be active volcanic systems beneath the ice. That's right, volcanoes under Antarctica. Heat signatures and seismic activity suggest that volcanic vents are pumping heat into the base of the ice sheet, contributing to the melting from below. And some researchers believe there could be as many as 100 volcanoes under the Antarctic ice, and many of them might be active. This geothermal heat wasn't accounted for in any of the climate models, which means our predictions about how fast the ice will melt have been dangerously underestimated. Let's talk about the magnetic anomalies. Scientific equipment has picked up strange magnetic field variations beneath certain parts of the ice sheet. These aren't normal geological formations. The magnetic readings are so unusual that some scientists initially thought their equipment was malfunctioning. But repeated measurements confirmed it. There are areas under the ice where the magnetic field behaves in ways that don't match any known mineral deposits or rock formations. And some researchers speculate these could be massive meteorite impact sites buried under miles of ice, containing metals and materials we've never studied before. Others have more exotic theories involving unusual geological processes we don't yet understand. The truth is, nobody knows for sure what's causing these magnetic signatures. Now, about those collapsing events happening overnight. Scientists have documented several instances where glacial ice that appeared stable one day was completely gone the next. Using satellite monitoring and seismic sensors, researchers have recorded the actual moment when massive sections of ice shelf simply give way. The sound these collapses make is incredible. The seismic waves they generate are equivalent to significant earthquakes, and they can be detected thousands of miles away. What's causing these sudden failures? The leading theory involves a process called marine ice cliff instability. Basically, when ice shelves that support glaciers break away, they expose tall ice cliffs. If these cliffs are taller than about 100 feet, the ice itself becomes too heavy to support its own weight, and the entire cliff face collapses. This triggers a chain reaction where the collapse of one section destabilizes the next, and the next, like a row of frozen dominoes falling into the sea. The economic and human implications of what's happening in Antarctica are staggering. If the West Antarctic ice sheet continues collapsing at its current rate, we're looking at potential sea level rise that would redraw the map of human civilization. Cities like Miami, New York, London, Shanghai, and Mumbai would face catastrophic flooding. We're talking about hundreds of millions of people displaced, trillions of dollars in economic damage, and the loss of some of the most important cultural and economic centers in human history. And this isn't a problem for the next century. Some projections suggest we could see several feet of sea level rise within the next few decades. The ice that's collapsing now is already committed to melting. Even if we stopped all carbon emissions tomorrow, the processes already underway beneath the Antarctic ice would continue. But perhaps the most unexplainable discovery of all is what scientists found when they drilled through nearly half a mile of ice in East Antarctica. They reached a subglacial lake called Lake Vostok, one of the largest lakes on Earth, and that's been sealed beneath the ice for potentially 15 million years. When they finally penetrated the ice and sampled the lake water, they found it teeming with life. Bacteria, yes, but also more complex organisms that have been evolving in complete isolation for millions of years. It's essentially an alien ecosystem right here on Earth. The genetic makeup of some of these organisms is so different from anything in our existing databases that scientists are still trying to understand how they fit into the tree of life. Some of the microbes have DNA sequences that don't match any known living thing. The implications for astrobiology are profound. If life can thrive in the isolated, dark, frozen world beneath Antarctic ice, then similar life could exist in the subsurface oceans of moons like Europa or Enceladus. The techniques we're developing to explore beneath Antarctic ice are the same ones we'll use to search for life on other worlds. But there's also a race against time. As the ice sheets collapse and these subglacial environments are exposed to the outside world, these unique ecosystems could be contaminated or destroyed before we fully understand them. We might be losing entire branches of the tree of life that we haven't even discovered yet. The data coming from Antarctica is challenging everything we thought we knew about ice dynamics. Traditional models assumed that ice sheets respond slowly to climate change, taking centuries or millennia to show significant changes. But what we're observing suggests that ice sheets can hit tipping points where they collapse much faster than gradual melting would predict. The warm water channels, the volcanic heat, the structural instabilities, they're all combining to accelerate the collapse in ways that weren't in the models. Some scientists now believe that we've already passed the point of no return for parts of the West Antarctic ice sheet. The question isn't if it will collapse, but how fast. There are also strange acoustic phenomena being recorded beneath the ice. Researchers have placed listening devices in the subglacial lakes and water channels, and they've picked up sounds that don't match any known sources. Some describe them as rhythmic pulses, others as almost musical tones. The leading explanation is that these sounds are caused by ice movement, water flow, or geological processes we don't fully understand yet. The extreme environment creates acoustic conditions that are unlike anywhere else on Earth. And sound travels differently through ice and cold water, and the echoes from the cavities and channels create effects that can seem almost otherworldly. But without more data, scientists can't say for certain what's generating all of these sounds. Let's address the climate feedback loops this is creating. As Antarctic ice melts, it pours fresh water into the ocean, which can disrupt ocean currents like the Gulf Stream. These currents are responsible for distributing heat around the planet. And if they're disrupted, we could see dramatic climate shifts far beyond just sea level rise. Some regions could get colder even as the planet warms overall. Weather patterns could become more extreme. The melting ice also reduces the Earth's albedo, which is its reflectiveness. Ice reflects sunlight back into space, but dark ocean water absorbs it, which causes more warming, which melts more ice. It's a vicious cycle that feeds on itself. And once these feedback loops get going, they're incredibly difficult to stop. The geopolitical dimensions are heating up too. As Antarctic ice melts, it's revealing potential mineral resources, oil and gas deposits, and opening new shipping routes. Countries around the world are eyeing Antarctica with renewed strategic interest. The Antarctic Treaty, which has kept the continent demilitarized and dedicated to scientific research since 1961, is under pressure as nations jockey for position. There's also the question of who owns the water from melting ice. Some companies have even proposed towing icebergs to provide fresh water to drought-stricken regions. Yet the pristine scientific preserve that Antarctica has been for decades might not stay that way for much longer. Scientists are working frantically to improve their monitoring systems. They're deploying more satellites, more sensors, more autonomous vehicles to explore beneath the ice. Every new mission brings back data that raises more questions than it answers. Why are some glaciers collapsing while others nearby remain stable? What role do the subglacial volcanoes really play? How interconnected are the water systems beneath the ice? Can we predict where the next major collapse will occur? The urgency is real because the changes are accelerating. The ice doesn't care about our political debates or our economic systems. It responds to physics and chemistry. And right now, those forces are pushing it toward a dramatic transformation. And some of the most cutting-edge research involves using artificial intelligence to analyze the vast amounts of data coming from Antarctica. Machine learning algorithms are finding patterns in ice movement, temperature changes, and seismic activity that human researchers might miss. These AI systems have identified potential early warning signs for ice shelf collapses, which could give us crucial time to prepare. But even with all our technology, Antarctica keeps surprising us. Just when scientists think they understand how the ice behaves, a new discovery upends their assumptions. It's humbling and terrifying at the same time. What can we do about all this? The reality is that some changes are already locked in. The ice that's collapsing now will raise sea levels no matter what we do, but we can still influence how bad it gets. Reducing carbon emissions can slow the warming of ocean waters that are melting the ice from below. Protecting and restoring natural ecosystems can help absorb some of the carbon we've already released. Investing in adaptation, building seawalls, relocating communities, redesigning infrastructure, these are all necessary responses. But time is not on our side. Every year we delay makes the problem harder and more expensive to address. The discoveries beneath the Antarctic ice are rewriting textbooks in geology, biology, climate science, and oceanography. We're learning that our planet is far more dynamic and interconnected than we realized. The systems that govern ice sheet stability are complex, involving factors we're only beginning to understand. And the life forms surviving in the most extreme environments on Earth are expanding our conception of where and how life can exist. These aren't just academic questions. They have direct implications for our survival and our future. So what's the bottom line? Antarctica is changing faster than anyone predicted. The ice sheets are collapsing in ways that science didn't think were possible. And beneath that ice, we're finding warm water channels, active volcanoes, magnetic anomalies, isolated ecosystems, and geological features that challenge our understanding of the planet. Some of these discoveries are explainable with further research, but others remain genuinely mysterious. What we do know is that the consequences of these changes will affect every person on Earth. The rising seas won't stop at any border. The climate disruptions will impact food production, water supplies, and weather patterns globally. This isn't just Antarctica's problem, it's humanity's problem. And the clock is ticking. The research happening right now in Antarctica is also teaching us something crucial about our own blind spots as a species. We've been so focused on understanding the surface of our planet that we've largely ignored what's happening beneath it. The subglacial environments that scientists are now exploring represent entire worlds that exist in the shadows of our awareness. These are places that have been shaping our planet's climate and geology for millions of years, completely unknown to us until very recently. It's a humbling reminder that despite all our technology and scientific advancement, there's still so much about our own world that remains hidden and mysterious. The bacteria and microorganisms found in the subglacial lakes are particularly fascinating because they're showing us new pathways for how life adapts to extreme conditions. Some of these organisms have developed proteins that function at temperatures where normal proteins would crystallize and become useless. They've created metabolic pathways that don't rely on sunlight or conventional food sources. They've essentially rewritten the rulebook for what life needs to survive. Medical researchers are now studying these organisms to see if their unique proteins could be used to develop new medicines or treatments for human diseases. The potential applications range from better vaccines to treatments for neurodegenerative disorders. And nature has been conducting experiments in these Antarctic lakes for millions of years, and we're finally starting to pay attention. What's particularly concerning to climate scientists is that many of the mechanisms driving ice collapse in Antarctica were completely absent from the climate models that governments and international organizations have been using to make policy decisions. The warm water channels beneath the ice, the geothermal heat from subglacial volcanoes, the structural instabilities caused by these underwater cavities, none of these factors were adequately represented in the models. This means that our predictions about sea level rise could be significantly underestimated. Some researchers suggest that the timelines we've been working with need to be compressed by decades. What we thought would happen in the year 2080 might actually happen in the 2040s or 50s. This is not a small adjustment. This is a fundamental recalibration of how quickly our world is changing. The exploration of Antarctica is also revealing clues about the planet's deep history. Sediment cores, pulled from beneath the ice, contain records of climate changes going back hundreds of thousands of years. Scientists can see patterns of ice advance and retreat, volcanic eruptions, meteor impacts, and periods of dramatic climate shifts. By understanding how Earth responded to these changes in the past, we can better predict how it will respond to the current warming. But here's what's troubling. The current rate of change appears to be faster than anything in the geological record we've examined. We're not just in a period of climate change, we're potentially in a period of climate change that's unprecedented in recent Earth history in terms of its speed. The acoustic phenomena being recorded beneath the ice are still not fully explained, and this is where things get truly intriguing. Some of the sounds that researchers are picking up have frequencies and patterns that don't match anything in our existing catalogues of natural phenomena. Scientists initially thought these might be water flowing through channels or ice fracturing, but the consistency and regularity of some signals suggest something else might be going on. One theory involves the interaction between seismic waves and the unique acoustic properties of the subglacial environment, and another involves previously unknown chemical or biological processes occurring in these extreme environments. The truth is that we simply don't have enough data yet to say definitively. But these acoustic mysteries are spurring more research and more funding for Antarctic exploration, which is ultimately good for science. There's also a fascinating connection between what's happening in Antarctica and what we might find on other worlds. The European Space Agency and NASA are both planning missions to explore the subsurface oceans of Jupiter's moon Europa and Saturn's moon Enceladus. These moons are thought to have vast oceans of liquid water beneath their icy crusts. The technology being developed to explore beneath Antarctic ice is directly applicable to exploring these distant worlds. The rovers and submarines being tested in Antarctic lakes and channels are prototypes for future missions to the outer solar system. In a very real sense, Antarctica is serving as an analog environment where we can learn how to search for life in places where we've never been able to go before. The discoveries we're making in Antarctica today are preparing us for discoveries we'll make on other worlds tomorrow. The economic models trying to calculate the cost of Antarctic ice collapse are staggering in their scope and complexity. We're not just talking about the direct costs of flooding and infrastructure damage. We're talking about cascading economic effects that are difficult to predict. If major cities are partially submerged, the value of real estate plummets. Insurance markets could become unstable. Supply chains that depend on specific ports could be disrupted. Agricultural regions could become unusable due to changed precipitation patterns. The global economy is intricately interconnected, and disrupting one part of it sends shockwaves through the entire system. Some economists argue that the economic cost of inaction far exceeds the cost of aggressive climate mitigation right now, but political will has been slow to catch up with the science. One aspect that often gets overlooked in discussions about Antarctic ice is the role of ancient ice itself. Some of the ice in Antarctica is over 800,000 years old. This ice contains atmospheric samples from hundreds of thousands of years in the past. By analyzing these ancient air bubbles, you scientists can see exactly what the atmosphere was like hundreds of thousands of years ago. They can measure carbon dioxide levels, methane levels, and other greenhouse gases. This historical data is invaluable for understanding how our planet's climate has changed naturally over geological timescales. What this research shows is that the current increase in greenhouse gases is happening at a rate that's orders of magnitude faster than any natural climate change in the past several 100,000 years. This isn't just change. This is unprecedented change happening at unprecedented speed. The indigenous peoples who live in the regions surrounding Antarctica are also being affected by these changes, though their voices are often underrepresented in international discussions about Antarctic science. The communities in Patagonia, Tierra del Fuego, and other southern regions have long-standing relationships with the lands and waters affected by Antarctic ice dynamics. Changes in ocean currents and temperature are affecting fish populations that these communities depend on. Changes in weather patterns are affecting traditional hunting and gathering practices. These communities have knowledge accumulated over thousands of years about how to live in extreme environments, and some researchers believe that this traditional knowledge could actually inform our approach to climate adaptation and resilience. But there's a risk that in our rush to understand Antarctica scientifically, we overlook the human and cultural dimensions of these changes. The future of Antarctic research depends on international cooperation and sustained funding. The Antarctic Treaty has been remarkably successful at keeping the continent dedicated to peaceful scientific purposes, but maintaining this requires commitment from nations around the world. Some countries have been reducing their Antarctic research budgets, while others have been increasing them. This creates an imbalance where we might not have as comprehensive an understanding of what's happening as we need. There's also the question of who has access to the discoveries being made. Should the genetic sequences of new organisms found in Antarctica be freely available to all researchers, or can they be patented? Should the data about mineral resources beneath the ice be shared globally, or does it belong to the nations that discover it? These are complex questions that the international community is grappling with. Looking forward, the next decade of Antarctic research will likely focus on improving our predictive models, expanding our monitoring networks, and deepening our understanding of the mechanisms driving ice collapse. New satellites are being planned that will give us even more detailed pictures of what's happening on and beneath the ice. More autonomous vehicles will be deployed to map the subglacial terrain and sample the water and sediment. Genetic research will continue to catalog and understand the life forms thriving in these extreme environments. Geophysical surveys will work to map the volcanic systems and understand their contribution to ice sheet dynamics. The scientific questions are clear, the research imperative is urgent, and the implications are profound. But beyond the research and the data and the models, there's something almost spiritual about what Antarctica represents. It's one of the last truly wild places on Earth, a continent dedicated to science and discovery rather than exploitation and development. The ice sheets that cover it are among the oldest geological features still visible on our planet. The life forms living beneath the ice have been evolving in isolation for millions of years. When we're standing at the edge of an ice shelf, looking out at the Antarctic landscape, or when we're diving beneath the ice into a subglacial lake, we're connecting with something ancient and powerful and fundamentally different from our everyday experience. Antarctica reminds us that Earth is still a planet of mysteries, still a place where we can make discoveries that fundamentally alter our understanding of life and geology and climate. The stakes of what's happening in Antarctica couldn't be higher. The ice melting there isn't just going to affect polar bears or penguins, though it will certainly affect them. It's going to affect you. It's going to affect your children and grandchildren. The decisions we make about climate change in the next few years will determine whether we prevent the worst outcomes or whether we lock in catastrophic changes that will persist for centuries. Antarctica is sending us a message through its collapsing ice sheets and its hidden ecosystems and its strange magnetic anomalies. That message is that our planet is more fragile and more dynamic than we've often assumed, and that the changes happening now are moving faster than our ability to fully predict or prevent them. So, as we wrap up this exploration of what's happening beneath Antarctic ice, the key takeaway is this. The frontier of science right now is literally the hidden world beneath the ice. The discoveries being made there are changing our understanding of biology, geology, climate science, and our planet's future. And the race to understand these changes before they accelerate further is one of the most important scientific endeavors of our time. The researchers working in Antarctica aren't just advancing human knowledge for its own sake. They're working to give us the information we need to make informed decisions about our future. They're racing against time, exploring a world that's changing faster than anyone anticipated, and uncovering mysteries that will occupy scientists for decades to come. And thank you so much for diving deep into this topic with me. If you found this exploration of Antarctica fascinating, please consider subscribing to the channel and hitting that notification bell so you stay updated as new discoveries emerge from the Antarctic continent.